we have seen the various plots that we can do using matplotlib and Seaborn. Now let us use it to do a exploratory data analysis of the Titanic dataset. So let's just load it using load data Titanic, and this is the head. So we can see the columns over here. This survived is the target. Our aim is to predict whether someone has survived or not given this information. That's so survived is our target column, and following options are class, in which class they are traveling. There is 1, 2 and 3 class, whether they are male or female, their age, whether they have siblings or siblings in the traveling with them, whether their parents or child is traveling with them, the fare they have given, which port they have uh, which they have boarded. There are 3 ports. Then which class is alive or alone. These informations we have. So as part of our exploratory data analysis, let's first see the shape of the database. So the shape is there is 891 columns and 891 rows and 15 columns. These are the column values and the data types of each column. We can see the average, the description of summary of the column values. Here we can see that the average age is around 29. Average fare they have given is 32, and so on. Now let's see how much values are missing. For that, we will calculate the missing value by df is null dot sum and sort value in the ascending form order, descending order, and we get the missing value and missing percentage. We can see the same thing as a heat map. So we can clearly see in age we are missing a lot of values. In which deck they have traveled, there also we are missing a lot of values, and few other values were missing in the embarked, and the town, embarked town is missing few values. The target which we have to analyze is survival. We just see how many have survived. So we can see that 549 people passed away in that accident and 342 survived. So more people has passed. Now let's see how the age is distributed. We use a histogram to plot that, and KD to see the distribution. So the average age is around 29, but there are older people. It is right skewed. The distribution is right skewed. Now let's see how fair is distributed. More people have traveled with the ticket fare, a smaller ticket fare, because class 3 people will be more compared to class 1 and 2. Like, this is also a right skewed distribution. Now if you, like we seen here, if you plot it as in a box plot, we know the central 50% come in this region, and anything outside this is outliers. So most of the people has traveled with a fare around, say, 30. Now let's go to the univariate analysis. So sex, how many males and females? There is around 570 males and around 300 females. How many classes are there? 1, 2 and 3 class. Like I said before, class 3 has more number of individuals compared to 1 and 2. And from which port they have embarked? There are 3 port, S, C and Q. From S, more people has embarked. How many people is traveling alone? Here we can see more people are traveling alone compared to comparatively. Now we'll move to bivariate analysis. We'll compare how many people survived in each sex. So in male, most of the people has died, only few survived. Female, it's the opposite case. More female has survived and less females only passed away. This shows that female and child first protocol they were following. Now survival by class. Many people in the third class has passed away and few have survived. But compared to that, higher class people have survived more. Now let's compare fare with survival. So like we seen before, the people with lower fare, more people has passed. So that's why here the median value comes closer to 0, and whoever has survived, the median is bit up. If they would have paid more, they would have had a better chance of survival. Now survival by embarked port. This doesn't give any clear distinction. Uh, Ports which they have boarded and the survival is random. We can't compare these two parameters from this figure. survival by traveling alone. So if they are traveled alone, there is a more chance to uh, die off. If we are traveling as a family, there's a higher chance of survival. The age distribution of survival, it looks like in every age group, half of them survived and half of them passed away. Now if you plot it using box plot, around people around 28, 20 to 40 age group is where the people has passed. I think this also doesn't give any clear identification on relation between survived and the age. Now survived with log fare. We have seen before we saw survived with fare. So higher the fare, more chance to survival. So we use here log of fare. We calculate the log and we can see clearly that higher paid people has a higher chance of survival compared to lower fare. Now let's do feature engineering. Feature engineering is nothing but creating new columns, deriving new columns from the available data. So we can create family size by calculating number of siblings and parent or child plus the individual itself. With that we can calculate the family size and then plot the survival. So each value is the average value of survived or not. So you can see as the family size increases, their survival possibility has increased, but it falls after the number of people has increased beyond 4 people. Now child versus survival. So if it was child, they have more survival chance, but adults, there is a more chance of passing away compared to survival if the individual is an adult. So here also, like we have seen, women and children were given higher preference for the during lifeboat, like protection was taken towards lifeboat. We can clearly see that over here. Now we can compare all this parameter using correlation analysis. We can see the class and fare is correlated, inversely correlated. First class will have higher fare, third class will have lower fare, and it's more correlated with log fare compared to fare. Family size is a engineered, I mean, feature which was calculated using siblings and the parent child count. So they are correlated. There's no surprise there. Siblings and parent child count is relatively has a correlation 0.41. So if there is a siblings, there's a high chance that there will be a parent as well or child as well. They will be traveling as a family. Uh, log fare again, higher log fare might be given if there is more siblings were traveling or parents will be traveling. You see, log fare is a feature derived from fare. We have more correlation with uh, log fare with this count compared to normal fare. Now, if you compare survived with other use cases, here you can see the lower classes has lower chance of survival. That's why it's inversely proportional, correlated. Age has a weak correlation. Sibling count, parent-child count also has weak correlation. Then higher fare give a higher chance of survival, and family size also have weak correlation. So final insight: women survived more than men. First class had higher survival. Fare is linked with survival. Family size impact survival. Missing values need to be handling before we start modeling the data. So this is how we do an exploratory data analysis, EDA, of a dataset. Thank you.